This video is part 2 of sampling and data, and we will be talking about sampling errors and bias. So let's talk about representative samples. We just finished the video where we talked about the different sampling methods, and we want to make sure that our samples are representative of the population we are studying. So example 3 says, decide whether each of the following sampling methods is likely to produce a representative sample. So to find the average annual income of all adults in the United States, sample representatives in the U.S. Congress. So the question is, does this sample represent our population? So the population is all adults in the U.S. Our sample is from the U.S. Congress. So will that be representative of all adults in the U.S.? Probably not. It's not a representative sample as it only includes those in Congress. All right, number 2. To find out the most popular cereal among children under the age of 10, stand outside a large supermarket one day and poll every 20th child under the age of 10 who enters the supermarket. So the population is children under 10, and it sounds like that's systematic because they're surveying every 20th child. So systematic sampling, and everyone in the sample is under the age of 10, so it would be representative of the population. Now, sample size matters. If 2 people take samples from the same group, their samples will almost certainly be different. And this doesn't mean that one is right and one is wrong, though. There is simply some natural variability in the samples. And it's just the way it happens. So bigger samples are often better. So one way to reduce this natural variability is to take large samples where the variation will get drowned out. So an example would be one MBA center in a sample of 10 people versus in a sample of 1,000 people. So for national polls, somewhere between 1,000 to 2,000 people is usually considered to be a big enough sample. Now, just because it's big enough is not going to guarantee good results. In general, self-selected samples or volunteer samples are not representative of the population. What that means is volunteer sample, it's a type of sample of convenience, but a volunteer sample is when you have people volunteer to answer. So think, Twitter polls and poll that the radio station does or that CNN does. Those are only people who want to respond. Oftentimes, people who volunteer their opinion are for online reviews, for instance, are strongly positive or strongly negative, one way or the other. They're like polar opposites. The people that are responding, the people that feel really, really negative are the ones that I see most often. So these volunteer response surveys are representative of the people that feel strongly one way or the other, but what about the people in the middle? So voluntary sample misses everyone in the middle who doesn't have a strong opinion. So those generally are not accepted. Actually, they're never accepted for valid results. They do them all the time, though, like the Twitter polls or Facebook polls and that kind of thing. And they're for fun, but they're not valid. They're not valid results because it's not representative of the population. It doesn't matter how big the sample is. So some other considerations that we need to consider when we're taking samples, besides having a sample that's too small, there are other conditions that can throw off a statistical study. So here are some types of biases. There's a self-selected sample bias or voluntary response bias. That's what we just talked about. The people that are responding to these voluntary ones are usually the ones with the stronger opinions. There's something called non-response bias. It's similar to voluntary response. Strong negative opinions get expressed more than others, and then the non-responders oftentimes don't feel as negatively, or they feel differently than the people that are responding. So non-response bias is when people, not everyone, is answering these surveys, and not everybody is represented. Another type of bias is self-interest bias. Self-interest is when the people doing the survey or the poll, they have an interest in the results. So studies sponsored by companies with a vested interest would not be considered valid. That would be bias. For instance, if Chips Ahoy Cookie wanted to do a poll on, whether you think their chocolate chip cookie is the best cookie or not, they're going to want people to say yes. So they might use bias methods, some methods in their polling to help encourage people to say Chips Ahoy. I'm not saying that Chips Ahoy does those kind of surveys. I'm just using that as an example. The point is, if a company has vested interest and they want to get valid results, the best way to go about it is to have an outside company do the polling for them, a company that does not have any vested interest, to avoid this type of bias. Another one is called social acceptability bias. So social acceptability is when the surveyee, the person being surveyed, may not give a truthful answer because they might fear being judged by anyone who sees their answers. So surveys about drug use or pirated music, you might not want to say if you've ever tried drugs, or you might not want to say if you've ever pirated music offline, or depending on who's asking the question, you might not want to say your true political opinions, depending on who is around when the survey is given. So weight is another one. I know that when I give my weight, sometimes I tend to shave off about 5 pounds when I give the number. Not that 5 pounds really matters much, but for some reason, it makes me feel better. So the point is that if you feel like you're going to be viewed negatively based off your answer, you may not give the most truthful response that represents your true feelings, true views, true information. For that reason, any projects, anything that we do in class, we will avoid the social acceptability bias at all costs. So if there is a question out there that could offend someone, as far as, not offend, but make them not want to answer truthfully because they feel uncomfortable, we're not going to ask it. So we're going to steer clear of that in this class. Then there's leading questions. This is when you put something in the question that will prompt a specific type of response, like, how badly do you think this Congress is done? Well, that, lost my page there. This word here, badly, was inserted into this question, and that makes the assumption that the Congress was bad. So, whereas this person might not think the Congress is bad at all. So, and this question would maybe prompt them to talk about, how badly they've done rather than how, good they think they've done, that kind of thing. So it's best to leave words like that out. A better way would be, what do you think? What is your opinion of the Congress on a scale of 1 to 10? How great do you how well do you think they've done on a scale of 1 to 10? But leave these leading and loaded words out of those questions. Then there's causality errors. That's assuming that a relationship between two variables means that one causes the other. So just because two things have a relationship doesn't mean that one has caused the other. This is related to a vocabulary word we're going to be talking about soon called confounding, and that's when the effects of multiple factors cannot be separated. So here we're going to go back into each of the biases just to make sure that we have a clear understanding. So self-interest bias, again, that's when those completing the study or sponsoring the study have a vested interest in the outcome, and they may be inclined to use biased methods to research the outcome they want. And here's that Chips Ahoy example. Social acceptability bias, that's when those being surveyed do not give truthful answers for fear of being judged or fear of offending someone. So an example here is different than the one I gave earlier. If you ask whether a subject always washes their hands after they go to the bathroom, while we hope the answer really is yes for everyone, that isn't necessarily the case. Someone might not want to admit that they may have forgotten to wash their hands in the past. So, hopefully people do, but, if you forgot, you're probably not going to want to admit it. Leading question. Here's some other examples of leading questions, like, do you like our excellent new ice mocha? The word excellent suggests that the drink is excellent and should be liked, so that we should take that word out. What is your opinion of our new ice mocha would be a better way to ask the question, and then you could give them choices: strongly dislike, no opinion like, strongly like. We talked about voluntary response and non-response earlier, but more clarification here. So a sample is obtained by allowing people to volunteer, and this is biased because people who usually answer are those with strong opinions. So the people that don't have strong opinions aren't usually represented. And then the non-response is when many surveys are sent to those who do not answer them, and the views of those who don't respond are different from those that do. Then there's a sampling bias. A sampling bias is created when a sample is collected from a population, and some members of the population are not as likely to be chosen than others. So you want to make sure that your sample is represented. So remember, each member of the population should have an equal chance of being chosen. So there's also sampling errors, which is not the same definition as sampling bias. These are errors related to the sampling process, such as sample size. Non-sampling errors are errors not related to the sampling process, such as a defective counting device. All right, so I mentioned this word earlier, confounding. This is when the effects of multiple factors on a response cannot be separated, and it makes it difficult or impossible to draw a valid conclusion about the effect of each factor. So here's an example that I hope clarifies it a little. A study is seeking to find a relationship between smoking and heart attacks. Because smoking is more prevalent among men than among women, a sample of smokers will contain a higher percentage of men than a sample of non-smokers. It is also known that men have higher risk of heart attack than women. So the higher rate of heart attacks in the smoking group may be due to the fact that there are more men in the smoking group and not to the smoking itself. In this case, being male gender is a confounder. So basically, if there's anything in there that may be causing the response other than what you're studying to be the response, like in this case, they were studying the effects of smoking, but if there's something else in there that could be causing this, that's considered a confounder, and that's called confounding. So we're going to stop this video here and pick up with part 3 in the next video.